Hey, what's up, guys? This is Chung here again. So, um, I wasn't quite sure if I want to talk about this problem, but since this is at least it's one of the second last questions problem in this week's weekly contest. So why not? Let's take a look anyway. So this is like number 1600 throne inheritance. As you guys can see, this one got a lot of downvotes. Actually, I also want to give it my own downvotes. Um, yeah, because the description is really confusing. That's why I don't quite like this problem. It took me a while to see the nature of this problem. Okay, so let's take a look. A kingdom consists of a king, his children, and his grandchildren, and so on and so forth. Okay, and once in a while, someone in the family dies or a child is born. And as you guys can see, there's like this. So this problem is like a design problem. It asks you to design like this kind of a few functions, right? So and then okay, so let's continue. So the kingdom has a well-defined order of inheritance that consists of the king as the first member. Let's define the recursive function, this one, and which given a person this an inheritance so far returns who should be the next person after this in the order of inheritance. Okay, so this is where it really gets confusing. So basically, so from here until here, this problem is trying to tell you how this inheritance order is defined. Okay, by using this successor method. Okay, but this part is really confusing. I'm not even sure if I want to go through this part, but I think it's better for us to jump into the implementation part. Okay, so basically, as you guys can see, we have an initial init, and then we have a birth, which means uh, this parent has a child, and then the death means this person just died. Okay, and then this is what this class is mainly for. It's it's trying to this one basically it should return the current inheritance order. Okay, so I mean, if you read through the successor functions here, basically the inheritance order is like this. You know, let's take a look, take an example here, and basically, if this person has any child, so those child will take precedence other than this person's siblings. Basically, let's say if this person has this is king, okay? So the king is always on the top. So the king is always on the top. And let's say the king has has two child, A and B, okay? And then the A has another two child here, which is like uh A, sorry, C and D, okay? And the B is also having two child here, like E and F. Okay, so I mean basically, so what's the order of this? This is 1, 2, 3, 4, 5, 6, and 7. Okay, as you guys can see, this is like the pre-order traverse of a tree, right? Basically, but this part, I mean, the way it's explained this method is really confusing. But in the end, it's just like a pre-order traversing of a tree. And to do the pre-order traversing of a tree here, all we need to do is we just need to define like a tree structures, and then we do a DFS. Okay, and of course, so we also need to maintain like another set to mark who is dead, who is already dead, and then when we doing the traverse, we just simply ignore that person. I mean, we can define a tree class, and then we have a left and we have a children's, right? But I think for me, I think it's more convenient or straightforward for me to just use like a dictionary. Basically, I'm just using a children dictionary here to do a default dictionary list. So basically here I'm only defining like the who is the parent and how many child this person has. And since the oldest child also gets the should have has the highest inheritance order, that's why I'm using a list. Basically, when I traverse this one here, I always traverse from the left to right. Okay, basically the so who got born first will have the higher inheritance order. Okay, and then I'm gonna have like a death maybe. Death have a set. Okay, I'll do a set here. And then the last one is what? It's just the king's name because we need the king's name to start the traverse. Basically, the king's name is the root node. Okay, and so here it's nothing more than just assigning this thing here. The parent name dot add child name. Okay, and then here it's simply just mark that person. We just add that person to this death set here. Okay, and here I mean we're gonna have an answer, right? That's gonna be our answer. And here I will just do a define a DFS here, uh, like a person. Okay, and then basically, if the person uh yeah, pre-order, yeah, this is pre-order, right? So this is in, yeah, pre-order. Okay, pre-order means we visit the root node first. Okay, so if the person not in self death, okay, then we do answer dot append this person. Okay, what? Hmm. Okay, and then we just do a for child in self dot children this person. Okay, and then we simply do a DFS of this child. That's how we do the pre-order traverse. Okay, and then the last one we simply start with what? With the self dot king name, and then we simply return the answer. That's it. Because we always start traversing from the king, right? Since we're getting the whole inheritance order here. Yeah. So this should work. Let's try to run the code here. Hmm? Oh, sorry. It's a list. It should be append. Set object is not callable. Hmm? It's not call. What? Huh? Which one? Okay. Is it because of this? Uh, dot add. I thought I did it right. Hmm. Let's see. Okay, I spent some time, troubleshooting here. So, this problem is really weird. So it seems like the reason being is that the death is one of the Python's built-in keyword. So which means, we cannot use the death here. We have to use like the this is like I think that it's a reserved keyword in Python. We can use the that. I think this should be okay. That okay. So we just use this stat here, and then we just run the code one more time. Cool. So as you guys can see, this one is passed. And let's try to submit it. Cool. So succeeded. All right. So I think that's it for this problem. You know, I'm not sure. I don't think it's a very good problem to understand to do in a especially in an interview. But I don't think you will get such interview question in a real interview because it's I highly doubt anything will try to explain something like this. I mean, it's a fun problem, you know, in the contest, but I don't think this is a good interview problem. Anyway, so just to recap real quick, basically we're just trying to build like a tree structures with the parent and the child, right? The parent and child uh, uh, relationship in the dictionary or in the hash table, okay, and the key is the parent and the values is the list of the children of this parent, and then we're also maintaining like a dead persons in this case, and then when we try to implement get the inheritance order here, we just do a pre-order traverse, which is the DFS, okay, and then that's it, just return the answer. Cool, I think that's it for this problem. Yeah. Thank you so much for watching the videos, guys. Stay tuned. See you guys soon. Bye bye.